Okay, so today we are talking about limits, and just to give like a big picture idea of what a limit is, the main idea behind a limit is just getting closer and closer to something. And I know that that sounds very broad and maybe isn't that helpful, but hopefully after going through this section, that will make more sense. So for us, that something is really going to be a number, right? So we are usually talking about functions, and so the limits that we'll be computing are going to be functions. That is, limits of functions. Okay, so let's think about a function f. So say the graph looks like this. And when we're talking about a limit, we're focusing on a particular point in the domain. So I'm going to just label one of these points A, and then notice that the function has this value here, which I will label L. So for this particular function that I've drawn, f of A is equal to L, right? Okay, now focus on the domain, so right around here, around A, and imagine you want to evaluate the function at some x values that are going to approach that number A. So I'm going to write that down. Or imagine you do evaluate the function so when I say x values, I mean values in the domain. That get closer and closer to A. And so this term closer and closer, you can keep that in your mind, but I'm going to start saying approach. So that's the terminology that we use in math to mean this idea of getting closer and closer. So let me demonstrate that in the drawing. And so the idea is, so say we start off and we evaluate the function at this point, so that would be up here, right? And then we take something closer, and that would give us a value here, and then even closer, but not quite at A yet. And you see that the values of the function sort of they lie along the curve, and they're getting closer to that point at the point A, and the values of the outputs at these points are approaching L, right? Okay, so what happens is, as we take values closer to A, the outputs at each of those are approaching L. And so in this case, we say that the limit as x approaches A is L, and we write this in this way. So we write LIM, and then underneath that, so directly underneath, we write x arrow A. So that's the part that means x approaches A. And then we write what the function, what we're taking the limit of, and that is the function f of x. Okay, so that whole part, it means the limit as x approaches A of f of x, and then if we know that that value is L, that thing that it's approaching is L, then we write equals L, right? Okay, So just make sure you have all of the pieces of this notation straight, and make sure your x goes to a, or this x arrow a, is directly beneath the limit symbol, right? Okay. So I'll remind you of that if you messed that up. Okay, so one thing to note is the way that I drew this, we were only approaching we were only approaching a from the right-hand side. But when we're taking a limit like this, we actually want to approach a from the left-hand side as well. So we want to approach from both sides. We just want to get closer and closer to a. So we would also want to evaluate points that get closer on the other side, right? And so the same thing happens, that as we take points closer to A, the values of the outputs get closer to L, right? Okay, so let's look at some graphs. So I have here 3 different graphs of these functions. And the thing that they have, that all of them have in common, is that they are discontinuous at 2, right? So here we have, so here's 2, we have a hole in the graph. That's what that open circle represents, right? In the second graph, we have a jump, so it's definitely discontinuous there. And then in the third graph, we have a vertical asymptote at x equals 2, right? So all graphs are discontinuous, or let me say, all functions are discontinuous at x equals 2. And the way I've written it makes it sound like literally all functions, so I'll say all these functions are discontinuous at x equals 2. Okay, that is true, but if you look at what's going on around x equals 2 on each of these functions, it's very different, right? So, however, what's going on around x equals 2 is very different for each of them, right? And so what limits do is they give us a way of talking about what's going on around a function, or sorry, not a function, what's going on around a point, right? So we could talk about what the difference is between each of these graphs around the point x equals 2, right? So limits give us information about what's going on around the point that we're approaching. Okay. Now, the intuitive definition of a limit, it's going to be a little bit more detailed than what I gave you up here. And so the idea is that the limit as x approaches a of a function f of x is equal to L if we can make the values of f of x arbitrarily close to L as but by taking x close to a. So we take x close to a, but not actually equal. So I'll talk more about this, but so notice that in our picture, the way that we drew this, the idea is that, say I want to get within, I don't know, some small distance of L. I want my function value to be within some small distance of L. Well, I can achieve that just by taking x close enough to a, right? So say, for instance, I need to take it this close to a in order to get, so let me draw this on here, and I use this color. So say I want to get within, I'll draw a straight line, this band of L, so I want my function value to lie somewhere in there, then I just need to pick x close enough that it falls within this interval right here. And I know that my picture got a little bit messy at the end there, but so that's the intuitive idea behind the limit.